Okay, let's talk about this extremely important, some definitions that go along with breathing and respiration. The term, most of you have heard of the term sleep apnea. So apnea means to quit breathing, the cessation of breathing. Hyperpnea means vigorous breathing, breathing usually deeper and faster than you need to. Eupnea is then normal respiratory rate. Okay, so a tidal volume would usually be eupnea. If you were exercising, you would have to go through hyperpnea, and then if you had sleep apnea, you'd be stopping your breathing during your sleep for some reason. Okay, hypoventilation is extremely slow, shallow breathing. You know, it can be an indication of certain conditions in the body or certain problems the body may be having, even though you can, consciously make yourself breathe extremely slow and shallow, but there are conditions that will trigger that. Hyperventilation is be the opposite, be where you're having deep or rapid breathing due to the accumulation of carbon dioxide and the low pH that brings about. Okay, one of the most common standardized test questions that often comes up when dealing with respiratory system is, do you understand respiratory acidosis and alkalosis, and do you understand the relationship between hypoventilation and hyperventilation to acidosis and alkalosis? So let's see if we can reason this out. So hypoventilation leads to increases of carbonic acid, and we call that acidosis. Hyperventilation leads to decreases in carbonic acid, that leads to alkalosis. So why is that? Well, when we look back at our chemical formula, we know that bicarbonate ion joined with a proton to become carbonic acid right before the enzyme broke that down into water and carbon dioxide right before we got rid of it. So if we have hypoventilation, that means that we are breathing slowly, which means then we are holding on to more carbonic acid. And if I'm breathing slowly and I'm holding on to more carbonic acid, then I'm going to become respiratory acidotic. I'm going to have respiratory acidosis. Hyperventilation, on the other hand, means that I'm breathing deeper and faster, which means I'm exhaling more of the carbon dioxide, which came from the carbonic acid. So if I have less carbonic acid, less acid, I become more alkaline. So hyperventilation then is going to either correct acidosis or it's going to lead to alkalosis if I'm hyperventilating. Now, we've often heard, and many of you have heard, that if you have a hyperventilating person breathe into a paper bag, then what that does, that causes them to reabsorb some of that carbon dioxide, which kicks in and makes the equation kind of go the opposite direction. So if somebody is hyperventilating, they're having respiratory alkalosis or becoming alkalotic or more basic. So if you reabsorb that carbon dioxide, then it actually reforms the carbonic acid, and so that would end the alkalosis, and of course you wouldn't want to inhale too much carbon dioxide or you become too acidotic. But anyway, I hope this makes sense, and it's all based on our understanding of that carbonic acid, that product that's made right before we exhale. So again, if I'm hypoventilating, breathing slowly, I'm holding that in, becoming respiratory acidotic. If I'm hyperventilating, I'm exhaling much more, getting that out. That could possibly lead to alkalosis. Okay, so a major part of test 3 will be, do you understand these equations and which way the equations are going? Now here, I'm actually in the lungs, or excuse me, I am actually in the tissues because everything is flowing down in this case. So we're in the tissues in this very first picture. So I'm telling you right now, the first picture is referring to the tissues. So what happens in carbon dioxide in tissues? Is carbon dioxide produced from the tissues going into the blood, or is carbon dioxide in the blood going into the tissues? Well, if it's going from the blood to the tissues, we would choose B for number 1. If it's going from the tissues to the blood, we would choose A for number 1. Okay, now look, how about number 2? What's happening here? Is carbon dioxide leaving the the red blood cell and going into the tissues, or is it leaving the tissues and going into the red blood cell? Okay, so if it's going into the tissues, we would choose B. If it's going into the red blood cell, we would choose A. Right? If it is going into the red blood cell, hint, hint, then it's going to join with water, and then once it joins with water, is it actually going in this direction or is it going in this direction? If it joins with water, is it then going back into the tissues? That's what A would be, because the arrow is pointing that way. Or is it going in this direction and going to become carbonic acid right there? So again, what this whole exercise is do you understand which way the gas is flowing in the tissues? There will also be a picture that will also represent the lungs, so you may need to make sure, am I dealing with the tissues or am I dealing with the lungs? Okay, now, then the next thing you have to do is that all the numbers are referring to the equations, and then A and B is also referring to what's going on in the equation. So A would be where the arrow is, meaning the equation is proceeding this way. B is over that arrow, so that means is the equation dealing with this in this direction. So you just need to understand which way is the equation that you're really choosing from each number, which way that equation is going according to if we're dealing in the lungs or we're dealing in the tissues. And then, of course, we're looking, am I talking about what's happening with oxygen or am I talking about what's happening with carbon dioxide? So it's really not hard, but you do have to keep it straight. So before you answer it on the paper, you definitely maybe want to, or answer it on the test in the Canvas test, you might want to write it down on paper and then make sure you go over it before you actually put it into the computer, and because after you submit it, you can't change it. Okay, here we see the same thing, except we're actually in the we're actually in the lungs, because I want you to notice here's the simple squamous epithelial cells of the capillary. Here's the simple squamous epithelial cells of the alveoli. So now what happens in the lungs? Does carbon dioxide leave and go into the alveoli, or does carbon dioxide go from the alveoli into the lungs? Does oxygen leave and go to the lungs, or does oxygen go from the lungs into the blood? So again, if you understand that, then the next thing you're going to do is you're going to choose, well, which arrow represents which way it's moving and which way because these are reversible reactions, so we have to decide, well, am I going from here to here for this, or am I going from here to here? Now, remember, when we start in one direction, we always keep following that same direction. We don't start one way in that direction and then move the other way, and that as far as the equation is concerned. So be consistent with which way the equation is going when you're working out the problems here. Okay, another part of the test, you got to, and by the way, if you've done the worksheets, this pretty much came straight from the worksheets, but you tell basically is what's occurring here in the lungs or the tissues. Now, again, I've said this 100 times already, I feel like. I know I didn't say it 100 times, but I've said it several times. If we say unloading or loading, we're saying in relationship to the blood. When is carbon dioxide unloading from the blood? When is oxygen loading into the blood? So make sure when you read these questions, that's how you're interpreting it. And then the way the arrow points is determining, when is basically carbonic acid breaking down into a proton and bicarbonate ion. When is it breaking down into those two? In the tissues or in the lungs? Because here, notice that this equation and this equation look almost the same, but one of them is happening in the tissues, one of them is happening in the lungs. So in other words, when does bicarbonate ion join back with the proton to become carbonic acid and then keep proceeding that direction? Is that happening in the lungs or the tissues? So those are things you've got to be careful about and pay attention to. So definitely, you definitely got to know this graph here. And you definitely got to know, our partial pressure differences. Now, before I show you the whole test, just want to make sure those are things you're paying attention to, since that is a big, big part of the test.